This might be the first thing you've ever done in math. That is, if you never go into any career that uses math, you're still probably going to do. This is statistics stuff. And if you work in business, if you work in finance, if you work in sociology, if you work in, there's lots of things, lots of places you could work where you might want to know something about statistics because it comes up a lot. What we're looking at today is the first step in a long list of steps we're going to take this year in regressional analysis. Now, this is where we have some data, and we're going to turn this data into a model that we can use to make predictions about something. The data that we have here, there's no physical connection with this data, but there could be. This could be like we could be looking at something like if we're in forestry, we'd be looking at maybe the height of a tree as a function of its circumference or as a function of its age in a particular forest. And we want to have some kind of a model that's going to make some predictions for us about that. That's just one example of many. So that in that case, x's and y's would have some real meaning. Here they're just variables. And just for now, we're just going to deal with this. Just how do we do the nuts and bolts of regression, and later on we'll apply this to some things. First of all, when we're looking at this table, this is a bad data table, but this is oftentimes how data tables are presented to us. It's not good because it's horizontal. We would much rather that this data table be a t-table. Instead of being horizontally displayed like this, we'd rather have the x's and the y's show up vertically. So for example, this first ordered pair, when x is 1, y is 36, just looks like an ordered pair, right? But it's not, so that's okay. I mean, we'll deal with it the way it is, but all this is like a sideways, like a tipped over t-table, okay? What do we do with this stuff? When we're trying to put data into a calculator, the first thing we're going to do is we're just going to plot this and see what it looks like. We're going to make a scatter plot of all this data in the XY plane. Whenever you want to input stuff into a calculator, you go to the stat screen. So everybody push the stat button. When you push the stat button, it takes you here to the stat screen. There are 3 menus. When I say menus, I'm just talking about these headings up at the top. If I were to move over to the right, I would get a different menu, right? Okay, the test menu is really cool stuff, but we're not going to do any of that this year. That's really pretty big time statistics stuff, and I highly doubt we'll get a chance to look at any of that this year, but eventually we'll get to that. The other 2 columns are very important, though. We're going to use those a lot. The first column is where we start, the edit column. If I want to put stuff into my calculator, I hit edit, and I get this. It's like a spreadsheet is all this is. It's hot here. Is it a little warm in here? Yeah. Maybe that's it. Anyway, so sorry, I didn't mean to interrupt things. This is like a spreadsheet. It's just like Excel. Raise your hand if you've used Excel before. I want to see how many people. Raise it real high so I can kind of get in there.
I think so.
So a lot of people have had some experience with Excel. It doesn't matter if you haven't. This is similar to that. It's not exactly the same, but it's similar. So the columns have meaning and the rows have meaning here. What the columns are, when it says L1 at the top and L2, what that really means, it means list. And when you're dealing with statistics or in math, when you're dealing with programming, computer programming or statistics, when you talk about a list, it just means a collection of numbers, collection of values. And so here's a list of numbers and here's a list of numbers. We're always going to organize our lists this way. If we always do it this way, we'll always know, we won't ever have to wonder how we're going to set this up. The L1 column, so the first list is going to be a list of our X values. The second list is going to always be a list of our Y values. And so it'll look just like a t-table. X and Y, they'll look like ordered pairs. Okay, but these are the wrong values, right? I want to put in this information, and I've got this information in there. And so what do? I got to get rid of it, right? The way I do that is I go up to the top of one of the columns and highlight, for example, the L2, and I hit clear enter. Now, if I push delete, delete, my voice is breaking here. If I push delete, look what it does. It deletes the whole column, and then you have to run out and buy a new calculator. No, you don't. You don't have to buy a new calculator. You can get it back, but that's not what we wanted to do, right? The delete gets rid of the column. I needed to just clear it. How do I get it back, though? I can just go stat, go down to 5, set up editor, and hit enter, And then when it says done, if I go back to stat edit, it's back again, right? But it still has data in it. I need to clear that. So I go to the top and I hit clear, enter, and it wipes out all the data, which is what I want. So I do the same thing for L1. I go clear, enter. It's all gone. Now I can start from scratch with my data. Okay, so how do you input this? You could just do this, like a book, left to right and then go down, but that's time consuming. It's not really made to do that. An easier way, a more efficient way is to put in all the X stuff first and then put in all the Y stuff. So my first X value is 1. I could hit the down arrow, but it's easier to hit enter because it's right down here by the numbers. So 1, enter, 7, enter. You just do the same. Just put all the X values in. 13, enter, etc.
I don't see the 7 button.
Okay? Okay, so once you get all those in, and you're probably done, once you get all those in, notice that if I hit the right arrow, it conveniently puts it up at the top of the Y list. So now I can put the corresponding Y values in. So the 36 goes with the 1, the 29 goes with 7, and just keep going. Okay? And then eventually we get all that data in there. So that, wouldn't you agree that if I were to plot this, that's going to correspond to 5 points on the graph?
Yes.
Okay? So how do I get this thing to do a stat plot for me? We're going to set this up one time. You never have to do it again. Then it'll be really easy to do stat plots. So real quick, everybody go second stat plot. So it's at the F1 button. And that's going to show you a summary of all 3 stat plots of the settings. All we really care about is the first stat plot. Okay, so it says plot 1, and it doesn't have to be a stat plot, but the default is a stat plot. So it should have that little symbol. That's the stat plot symbol, or the scatter plot, I mean to say, not stat plot. The scatter plot symbol. Then it should say L1, because then it's going to do X's, and then it should say L2 for Y's, and then it should have that little tiny box there, which is going to be what it's going to put every place there's a data point for each one of those ordered pairs. If yours looks just like that, then you don't have to do anything. If it doesn't, you can hit enter to turn that first stat plot to go inside the settings and change things. So it should always be set to the upper left, L1, L2, far left mark. Okay. Once you get it like that, just hit second quit. And even if you didn't go to that menu, just hit second quit and go back to the home screen. Okay. What did we just do? Well, we set up the stat plot 1 to be a scatter plot, which is what we want. How do I turn it on? Well, I could have turned it on in stat plot, but here's how we're going to do it in the future, so I'll show you here. If you go to the Y editor, this is probably the most important screen on the whole calculator. It's a graphing calculator. This is where we graph stuff, right? So if I want to graph, for example, the function y equals x squared. You guys know how to do this. If I want to graph x squared, I just put an x squared there. And if I hit zoom 6 to kind of reset the window, there's my function. I already graphed it for me. Okay? That's not what I want though, is it? I don't want x squared. I want to get this scatter plot. So I'm going to go back and clear that. And I'm going to go up and turn on plot 1. To turn on a plot, you just go up and highlight it and hit enter. And notice when I do that now it stays highlighted. Okay, even if I go back down to Y1, that stays highlighted, which means it's been turned on. Okay? But if I just hit graph, or even if I hit zoom 6 to go to the starting place, that doesn't work well for me because that doesn't fit my data well at all. Look at my data points. These Y values are pretty big. So the data points are all going to be up here. I don't see any of them. There's a way, instead of having to go through and custom build the window to see the data, the calculator will do it for you very simply. Once you put the data in and turn the plot on, the plot has to be turned on, but once the plot 1 has been turned on, I can go to the zoom menu, and if I were to scroll down, I'm not going to do it, but if I were to scroll down, the 9th option would be zoom stat. Okay, that's the one that I want, so I'm just going to type a 9 in there. And that corresponds to zoom stat. And look what it does. Okay, now it sizes the window so it fits my data. Okay, pretty cool. So there's my scatter plot. That's a plot of all 5 of those points. Now, the first level of our model here is just kind of visual. Is there a relationship there? What do you think? Is there a pattern? Yeah, what does that look like? If you had to describe, it's not perfect, but what basic shape is that? Say it again? It's, well, okay, kind of like check, but it sort of looks, I mean, it's not going to be perfect, but doesn't it look like a line with a negative slope? It's not perfect, but it's not going to be. When you use real world data, it's never going to fit something perfectly. We're trying to find what describes it the best. Well, in this case, a line describes that really well. So we would say that this is a linear distribution, because it's a line. And if we want to talk about the correlation, what kind of slope does that line have? It's got a negative slope because it goes downhill from left to right. So we'd say that this has a negative linear correlation, right? Another way of thinking about that is, wouldn't you agree that as my x values are increasing, the y values are always tending to decrease, right? And so that's what that negative correlation means. X goes up, y goes down. Also produces a negative slope. Now, what if I got a different graph where the data started at the bottom left and moved up to the top right? Well, that would have been a positive correlation because the best fit line has a positive slope. What do you suppose it would be if the data was just randomly shot all over the screen with no rhyme or reason? No correlation. Yeah, there wouldn't be any correlation. There's no connection between x and y. As x increases, we don't have any, who knows what y is going to do. It's random. Even if I got a bunch of data that just kind of stayed at the same y value as I went across, it wasn't going up or down, that also is no correlation because as x increases, y isn't changing. There's nothing interesting going on there. The relationship doesn't predict any kind of a positive or negative change. So that also would be no correlation. Okay, but beyond that, that's good. But those answers always have those questions always have one of three answers. What's the correlation? It's either positive, negative, or no correlation every time. We can do better though. Ideally, we'd like to come up with actually a specific line that we can all agree on. That's the best fit line. Now, wouldn't you agree that if I wanted to draw the line that best fits the distribution, it's probably going to look something like, if I were to go down, something like that maybe, roughly. It's going to sort of follow the trend. Does it ever have to go actually through any of the data points? It never has to go through any of the data points. But it has to describe the pattern of the data points, right? That's what a best fit line does. Now, the problem is, if I handed this out to all of you guys and said, draw the best fit line, they'd probably do a good job. They'd all look basically what it should look like. But you suppose that your lines would all agree exactly? There's no way. They're not all going to agree exactly. They might come close, but everyone's going to have a slightly different interpretation of what that best fit line should be. That's not very mathematical. We want to come up with an equation of the best fit line. There is a process for doing that in statistics called regression, called linear regression. It's a really ugly looking equation that I'm not going to even show you. That's what you would maybe look at if you were in a little more advanced statistics class, but not an Algebra 2 class. We're not here to do statistics, really. We want to use statistics, but we're not going to worry about how they're produced and all the theory behind it. Fortunately, the calculator does those kinds of calculations really quickly and easily. And so we're going to rely on the calculator, or you could also rely on like an Excel spreadsheet or a computer program to do this. So how do we do that? Well, everybody say this once. Before I show you, I want you to say this. Stat Calc 4. Stat Calc 4. Say it again. Okay, say it one more time. Okay, here's what that means. That's something, if you Stat Calc 4 gets you a lot of mileage in this class. Stat Calc 4, if I do that, if I go Stat, right arrow to get to the Calc menu, so that's Calc. Stat Calc, fourth option is linear regression. So Stat Calc 4 gets me there. And yours hopefully looks different than that. If yours looks like mine, it means you have an old operating system, and I will upgrade it with one of our calculators, update it to a newer operating system. But it should look fancier. It should say linear regression, then under that it should say, is it L1? Okay, L1, and then it should say after that it says X, is that right? Oh, X list, L1, Y list, L2, and then it says something weird like, frequency list, and it should say nothing, we'll never use that. And then it says something, store regression equation, store reg EQ. And then at the bottom it says calculate. Yeah. Okay, most of the time, If we're just wanting the equation of the best fit line, we can skip all the way down to calculate and just hit enter. So do that real quick.
Calculate?
You get that, or something very much like that. Don't panic. If you don't get exactly that, it's okay. All I care about at this point is that you get the A and the B numbers. The R squared and the R. Later on, we'll change it so yours shows that too, but for now, we don't really care. Okay? So everybody got that? It says A and B. Look what that did. Did yours do it? Okay, so you just do this for now. There you go. Okay? So what does that mean? That's really powerful. What the calculator just did for us, listen please. So what the calculator just did, it just went through that whole huge calculation for our data, and it found that if I write the best fit line in the form y equals mx plus b, they use an a for some reason instead of an m. I don't know why, but they called it an a. That's fine. So a is really the slope. Then these are the values that I would plug in for a and b. The slope A would have a value of negative 1.470, blah, 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 blah. Right? It gives me a hugely precise value for the slope of the best fit line. What's the y-intercept? Well, it's 37.26937, blah, blah, blah. Right? So it gives me this big long decimal that gives me the exact B value for the y-intercept. And so in Moodle, there's a lot of questions that are going to say, okay, for this data set right here, what is, for example, m, rounded to 3 decimal places? So we would just write in negative 1.470. That's the answer. Your calculator does that all for you. Okay? If it asks for b, I would type in that answer, rounded to 3 decimal places. Okay? No big deal. Now there's one more step though. There's one more thing that I want you to be able to do that's really valuable. So this produces the equations, but more often than not, we want to use this regression because we want to make some kind of a prediction. Okay? So we might want to know, for example, what is the most likely outcome when x equals 7, y equals what? What's the most likely outcome for y? What do you think? 29 is the obvious answer, but it's not the right answer. I'll show you why. Because if we look at this distribution here, if I graph the best fit line over the top of that, what are the odds that it actually goes through that data point? If it does, then the answer is 29. But if it doesn't, there might be a more likely value that the line gives us. Okay? So the next step is, how can we get the calculator to actually put the graph of the line, the plot of the line on this graph next to the scatter plot? Here's how you do it. So we're going to go stat calc 4 again to get to linear regression screen. And then on the step where it says store regression equation, we want to put a y1 there. So we want to store it as y1 so it'll graph it just like it would normally graph a y1. Okay? So how do we do that? Now mine, I have the old system, so I'm just going to put the y1 right there. If you have a TI-84, there's a shortcut, remember. You can just go alpha F4 and you get that little pop-up menu with all the y's. Okay? So I could just hit enter and it puts the y1 right there. What if I don't? What if I don't have a TI-84, if I'm working with a TI-83, or if I forget the little shortcut? I can always just use the menus on the calculator. I can go through the menus to get to y1. And the way you do that, it's not as confusing as it might seem. You go to the variables menu, because I want a y variable, right? So I'm going to go to the variables menu. I'm going to scoot over to y variables, and I want a function, none of that other weird stuff, right? So I want a function, and I want y1. That also puts it in there. Either way. When I hit enter, though, or you hit calculate at the bottom, it gives us the same information, so big deal. What did it do? Well, that's what it did. It took that big long equation and it actually inserted it into y1, right? And so now if I hit graph, look at that. There's the regression line. Gave it to us, okay? And so what we want is we want the actual value, the predicted value from our model. When x equals 7, what is y? Well, the way we can get to that is if we go, when I've got the line graphed and I want to do something with the graph, remember we always go to second calc. Then I got this list of all these things I could do. Well, I want value. I want to evaluate my line, my function. So I hit 1 when x equals 7. And if I hit go, it tells me that no, 29 is not the most likely value. The most likely value is 26.976. Okay? And you're going to the first time. Once you've done this once or twice, it'll stick. So one more time, let me do that again. So once we get this thing graphed, and the way I graph it is stat, calc, 4, and I got to pop a y1 in right there, right? So alpha, y1, enter, then it puts it in for me. Okay, so now I've got this line. To find the y value for a certain x value, my trick is second calc value 7. Okay, there's a shortcut though that I'll show you. It turns out, now I know I took some time showing you that scatter plot stuff, right? The scatter plot is sometimes of a little bit of use, but not very often. There are going to be like 4 questions on the assignment that ask you to use the scatter plot to tell what the correlation is. Once you're done with those, you can turn it off. You never need to really use it again for a long time. We don't really need it for this. So I'm going to go to y equals, and I'm going to go up and unhighlight it to turn it off. And the reason I'm doing that is if I only have one thing graphed on there, if I just have the y1 graphed and nothing else, there's a trace trick I can do. Once I've got the line, instead of having to go through that whole process of second calc value, if I want to know the y value for an x value, I can just hit trace and type the x value. So trace 7 and hit enter, and that gets me there a lot faster. So that's the trace trick. But everything else has to be turned off. Okay? Yes, sir. Question?
So where do you put in the y1 if you have the
83?
fancy thing?
Well, if you have the fancy one, you can just go alpha F4. And you put it on store regression equation.
Okay.
Right next to store regression equation. Okay? Now, does this seem a little weird? Just tell me if this bothers you a little bit, that when I asked you for the most likely y value, it wasn't 29, even though that's the value that we got. Maybe we're measuring like the height of a tree that's 7 years old. It really was 29 feet. Does that mean that in that forest, though, that if I were to measure another tree that was 7 years old, that its height would likely be 29 or 26.976? Is it weird that's a better answer than 29 to you? Think of it this way. If I had everybody in here flip a coin 10 times, would it be bizarre if a single person got a result of 9 heads and 1 tail? I mean, wouldn't somebody get a pretty lopsided result like that? Most people would get around 5 and 5, right? But somebody in here is likely to get a pretty lopsided one. That's not that big a deal. If you, out of 10 flips, 9 of them could be heads. It's not going to happen very often, but it could happen. Now, what if we did this with 100,000 people in Oregon, and they all flipped it 10 times, so 1 million total flips? Would it be weird to you if 900,000 of those were heads and 100,000 were tails? Could that happen? Well, I mean, I guess out of an infinite realm of possibilities, it's possible, but let me just tell you that if you were to do the calculation, it'd be a pretty easy one to do if we want to take some time. It would, if people did this, let's say they could do this, and let's say we could flip the coin and compile the results once a second. Everybody, all 100,000 people flip it and input it, and we'd see the results once a second. It would literally take something like 1 trillion times 1 trillion times 1 trillion times the age of the universe before that ever happened. It would effectively never happen. You could never get something with 1 million flips. You could never get 900,000 of one and 100,000 of the other. The odds are so low that it would essentially just never happen. So what's the big difference? How come flipping it 10 times, no big deal, 1 million times, impossible? That's a principle in statistics that's really important. What that's saying is that the more data you have, the more times you do something, the more it tends to gravitate towards its average value. If I only flip a coin 3 times, I mean, I might get heads 3 times quite often. That's no big deal. But if I do it 1 million times, it's going to be about 50-50. It doesn't mean it's gonna be exactly 500,000 heads and 500,000 tails. It might be 500,082 heads. But still, 82 out of 1,000,000, that's not that big a difference. It's still almost 50%, isn't it? Very, very close. You see my point? So that's what this is doing for us. When you do linear regression like this, you're taking the strength of all that data to build a line that gives you a better prediction than any one weird data point. One data point can be off by a little bit. But the more data you have, the stronger the model as a whole is. Okay? So now what if though, what if we want to do something beyond this a little bit? Let's say that we want to look outside of our data. Let's say we want to instead ask the question, when x equals, how about 30? What does y equal? Well, the same trick should work, and it will, but not exactly the way we have the calculator set up. If I try my trace trick, if I go trace 30, it's going to break. It says error, invalid. Now, when you get these error messages on calculators, don't just hit quit. Don't be a quitter. Go down to the second option, which is go to, and hit enter, and it'll tell you why it broke. What happened? Well, the problem was with the 30. It didn't like the 30. Something was wrong with that. The calculator wasn't ready for 30, and here's why it wasn't ready. Because our window wasn't big enough. The value that we input for x has to be within the range of values that our calculator is expecting. So the window only goes from, on the left, x equals negative 0.9, to on the right, x equals 21.9, which is great for this data, but not if I want to look outside of the data, clear out at x equals 30. So what do? Got to make it bigger. I'm just going to go down to x max and make it something like, how about 35 or 40? It doesn't really matter, but something bigger than 30. And now if I hit graph, look what it does. It stretches the screen out to the right. The only problem is now my line runs off the graph. It still would work and give me the right answer, but it doesn't look very good. So instead, whenever you change the x values like that, instead of just hitting graph, hit zoom 0, which is zoom fit. What that's telling the calculator to do, you'll do this a lot this year, is I change the x's. Now, the calculator's pretty smart. Let it figure out the y's that go with those x's. It'll fit the y values to the x values that I fed it. So zoom 0, it'll think for a second, and it'll graph it so it looks better. Okay? So there's my new screen. It's been extended. Now I can do my trace trick and go trace 30, and there's the answer. There's the y value that goes with it. Okay? It's a lot of stuff. I know that's a lot of stuff. What I want you to do, you're going to hustle down to the lab. I want you to do a problem from the new problem set before you do anything else. See if you can do one of each kind of those two. Once you've done that, I don't care if you just put it away for now. We'll come back to it later. But I want you to do one of these so it sticks.